Reflections. The objective of this video is to identify and graph reflections of parent functions. The key concept in here is to reflect over the x or y axis. That is represented by a negative because a negative will just produce the opposite number. So again, if we are affecting the entire function, meaning it's on the outside, we're reflected over the x in the x-axis. And if we are affecting directly the x, then there is a reflection over the y-axis. So a reflection, again, is just like a translation. It does not change the shape of the graph, but it will produce a mirror image, meaning that if I were to fold these two, the parent function and its reflection, along its reflection axis or line of reflection, I would basically be folding it in half and having two images that are copies of the other. So bringing back that guide I had before for translations, we're going to add on two negatives to represent a reflection. So if I have a negative on the outside, the green one, that would be a reflection over the x-axis. So reflection, x-axis. And the purple would be reflection over the y-axis. Again, you want to start with drawing your parent function. So my absolute value function. The reflection now is on the outside, is not directly affecting x, so it's a reflection over the y-axis. So we are going to change. The 0, 0 does not flip over because it's directly on the axis. But now these other two will just flip. I'm going to start off by graphing my parent function. And now I'm having a reflection over the x-axis, which basically means that my line here is just going to flip over and it will be on top. And my line over here will flip over and it'll be at the bottom, because that negative is applying to the entire axis. Now, in this case, it can also be construed that this negative is applying to the x, because there are no parentheses to say this is solely happening to the x. However, it will look the same, because if I were to reflect my image here, let's pretend this one, to the other side over the y-axis, I'm going to end up in the same place as a reflection over the x-axis. That's why it does not matter in this specific case, because we're going to end up with the same image regardless. So that just means that my new image will be right here. My asymptotes do not change because there is no shift anywhere. You should try and do these problems and then press play to see if your answer is correct. Pause your video now. So I started out by graphing my parent functions. The first one is negative x squared, which means I am going to flip over the x. So that just means I'm going to start off, my 0, 0 stays the same, but now it's negative 2, negative 4, and 2, 4. You can also verify this by creating a table with your new function, and you can verify that your graph is correct or that your points are correct. just to see if you're doing it correctly. The next one, negative x, the negative is actually inside. So that means we're going to flip over the y-axis because we're directly affecting the x. So my points here are going to end up just on the other side. So instead of 4, 2, it will be negative 4, 2.